All right. A logarithm is a way to write an exponential expression in different form. And all logarithmic form is it takes the same components of an exponential form, some number to some power equals some number, 2 to the third equals 8, 10 to the second equals 100, something like that. And they transform it into log of x base b equals p. That's how you read this. Let me start off with the correct way to read this. Log of x base b equals p. That's how you read that statement. All right. And if you notice the pieces where they come from, if I have b to the p, b is the base, right? Yeah. And notice log of x base b, b is still the base. It's located underneath the g of the logarithm. The answer to the exponential expression is the argument of the logarithm, log of whatever, the whatever is the argument. And then equals p, p is always the power. And it doesn't matter what you have in your statement, that's all a logarithmic expression is. And it goes the other way also. If I'm in logarithmic form and I want to go back to exponential form, this base raised to this power equals that number. So if I have log of cat base dog equals mouse, if I have that statement, log of cat base dog equals mouse, that means that dog to the mouse power is equal to cat. Doesn't matter what's there, just whatever's in those positions, that's all it is. That's all it is. It's just a rewriting of the same expression in a different form. The purpose of logarithms is when you get b to the p power, you can get rather large numbers. All right? If you do a logarithm, it gets it down to the power being the result as opposed to the base raised to the power, so you can take a really extremely large number and work with it in a smaller form for a while and then put it back into the big form if you need to. That's its purpose. All right, but that's all a logarithm is. And the buttons on your calculator for logarithm, open that up because for some reason it's closed. There's two buttons on your calculator to do logarithms. There's LOG and LN. Let's focus on those two buttons. So start off with the LOG button, that's the base 10 logarithm. Then you have the LN button, that's the base E logarithm. And if you forget which one's which, it's real simple because right above log it has the 10 to the power, right above ln it has the e to the power. So it lets you know that. But if you have log base anything else, your calculator, as of right now, can't do it. There might be a way to do it, I'll tell you later. But for right now, we'll pretend your calculator has no ability to do logarithms except for base E and base 10. All right. There will be times when we might be able to, we might be able to monkey around with the bases a little bit and make them work. But for now, just believe that that's the only two bases your calculator can do. All right. So example 1 is simply rewriting things in exponential form, rewriting logarithmic expressions. So it's basically just a matter of looking at the expression of each time and then rewriting it properly. The base of the logarithm raised to the power equals the argument. So 2 to the third power equals 8. The second one, base is 10, raised to the second power, so 10 squared is equal to x plus 5. Okay. Now, problem B is a logarithmic equation. That's something we'll be dealing with in this chapter. Notice that in logarithmic form, it looks really difficult to solve. Once I change it to exponential form, it just becomes 100 equals x plus 5, so x equals 95. So it'd be very easy to solve a logarithmic equation if you could transform it to exponential form. And that's a process that you're going to look at. If you have an exponential form, sometimes getting it to logarithmic form makes it easy to solve and vice versa. So just something to think about. As far as the question was concerned, though, that's what they were looking for an answer. They're not looking for you to actually solve anything right now. All we're doing is transforming. LOG base E and LN mean the same thing. They're interchangeable. So a lot of times they'll write log base E, sometimes they'll write ln. Just know that they mean the same thing. For the sake of transformation from exponential logarithmic form or vice versa, this is a better form to look at for transformation back to exponential form. This base raised to that power equals the argument. And finally, log of b cubed base b equals 3. The base is b, the power is 3, and the argument is b cubed. So b cubed equals b cubed. Well, which it does, right? This is actually one of our logarithmic properties we're going to be looking at in a moment. if the argument space and the log space are equal to each other, the power is the answer. So in general, if I have log, let's say base 7 of 7 to the 10th power, that equals 10. If I have log of 100, log without any base written is understood to be base 10. Keep in mind that 100 is 10 squared, and the bases match, so the answer is 2. All right, so that's just a property we're going to be looking at in a moment with example 3, I believe.